These are notes 8.3 for Algebra 1, and today we're going to talk about solving not necessarily just equations, but quadratic equations by factoring. So let's just do as a quick review. Remember, a quadratic equation is one that's in the format ax squared plus bx plus c. We've been using these types of equations now for a while. And we know from our previous lessons that to solve the quadratic means to find the solutions. And the solutions to a quadratic are also called the x-intercepts, the roots, or the zeros. All of these can be used interchangeably as names for finding the solutions or to solve the quadratic. So the solutions to the quadratic equations are located where the curve or the parabola crosses the x-axis. And so if we are looking for the zeros or the roots, the x-intercepts, we're looking for where y is equal to 0. And just as a reminder, you can have 1, 2, or no solutions to a quadratic. And let's just review that real quick. Okay, so if I were to draw a coordinate plane and to draw a quadratic that came down like this and just touched in one spot like that, that's one solution, because this is where y is 0. So there's your x-intercept. It's only crossing one time. Now what if I had a quadratic equation that looked like this? What if it went upside down and it hits right here and right here? Again, this is where y equals 0, because all along the x-axis is where y equals 0. And so we have two solutions on that one because it crosses the x-axis in two places. And then finally, if I had a quadratic that looked like this, let's say I have one that graphs like that, or maybe one that graphs like this, and it never crosses the x-axis, so that's no solutions. Now, today what we're going to learn then is how to determine what the values of these solutions are. How do we know what the values are? And the way we're going to do that today is by factoring. Now, you've been doing factoring a while, so we're just adding a little step to what you already know. So it says solve this equation by factoring. And so we have x times x minus 18. Well, it's already been factored for us. Okay, that equation's already been factored. And so it tells us to set y equal to 0. So we're always going to say that 0 is equal to this. And you have to know that if you have two numbers that multiply and you end up with a 0, that means either this one's 0 or this one's 0, because you have to multiply by 0 to end up with 0. So the way we use that to find our factors is we do them both. We say, what if x was equal to 0? What if x minus 18 was equal to 0? And we try them both. So on the first one, x equals 0, and again, this is all typed out for you already. We have nothing else to solve. We know that x equals 0. And if x minus 18 equals 0, what's x going to equal? Well, we have to solve that, so we're going to add 18 on both sides. So x equals 18. And there's your two solutions to your quadratic. We set them equal to, set your factors equal to 0, and then we solve the little mini equations. Now, it shows us here that we can check our work by plugging our solutions back into the original equation. So let's go down here and try it. So you can see here on the notes, remember our original equation was y equals x times x minus 18. So what they're saying right here is we said one of the solutions was 0, and we want y to be 0. Remember, that's where the solutions occur. So we're going to plug it back in. So we're going to take the first solution, 0, and plug it in anywhere we see an x. And so 0 minus 18 is negative 18, and we have 0 times negative 18 is 0. So does y equal 0? Yes, so it works. Now let's try the other solution. Remember, we want y to equal 0 in the end, so we're going to put 18 everywhere that we see an x. So we're going to do 18 times 18 minus 18. And so 18 minus 18 is 0, so you get 18 times 0 equals 0. And that's what you want. When you plug it back in, you need to see that both solutions will make the equation end up equaling 0. Okay, now, okay, well, I got interrupted about maybe 5 hours ago when I was making this video, so I'm not sure where I left off, but on our question, we had solved this equation, and we got x equals 0 for one of our solutions, and x equals 18. So when I put that into y1 and I graphed it, you can see that it crosses the x-axis where y equals 0. So it's at 0, 0. And then this one over here, you can't tell it from this picture, but it's at the 18, and so it's at 18 comma 0. So in both cases, y is equal to 0, and you can see from the graph that it's hitting at the right place. So that's kind of what I wanted you to see. Okay, so let's go back to the worksheet. So you can see this little call-out box is just a reminder about how to find solutions. We're going to set the equation equal to 0, then you're going to get your factors, then you're going to separate the two equations and set them both equal to 0, solve each little mini equation, and then you'll get your solutions. You might have one solution, two solutions, or no solutions. And then you can check them by putting them back into the original equation and making sure it comes out to 0. So let's look here at number 2. We're going to do this, and so we're going to say y is 0. 0 is equal to x minus 3 times x minus 8. So at this point, we are going to separate these two factors into two separate little mini equations. So we have x minus 3 equals 0 and x minus 8 equals 0. Now we just solve for x. So we do that the same way as always. We're going to add 3 on both sides, and so we get x equals 3 for this one. And we're going to add 8 on both sides for this one, and so we get x equals 8. So the solutions to our equation are 3 and 8. And we can write them like that as a set, or we would say 3 comma 0 is one solution, 8 comma 0 is the other solution, remembering that y is always 0 when we find solutions to quadratic equations. Now, if we wanted to check this, I'm going to do this up here in this nice open space up here. Okay, so let's start with x minus, with 3 being the solution. So if I put 3 in for x, I get 3 minus 3 times 3 minus 8. And what is 3 minus 3? 3 minus 3 is 0, and 3 minus 8 is negative 5, and 0 times negative 5 is 0. And if we were to put 8 into our solution set, we would have 8 minus 3 times 8 minus 8. And 8 minus 3 is 5, 8 minus 8 is 0, and 5 times 0 is 0. So we always want to make sure it comes out to 0 because that's what y is supposed to be. Okay? So let's look at some of the problems on the back. Okay, so on both of the samples that you had on the front, the quadratic equation was already factored for you. Now we're going to have to factor it ourselves to figure out our solutions. So remember, we want y to be 0, so we're going to say 0 is equal to x squared plus 13x plus 36. And we're just going to factor it the same way that we did back when we were doing our factoring lessons. So a is 1, b is 13, c is 36. So our sum that we're looking for is always going to be b, is 13, and our product is a times c, so that's going to be 36. So we're looking for two numbers that when we multiply them together will give us 36, and when we add them together it'll give us 13, and those two factors are going to be 9 and 4. So now let's go ahead and factor our quadratic. So we're going to break up the b, so we have x squared plus 9x plus 4x plus 36. And now we're going to divide under upside down division, and so I'm going to take out an x, and so I have x plus 9. Bring my x down, and upside down division again. This time I'm going to take out a 4, and I have x plus 9. Bring down the 4. So what's outside the parentheses, x plus 4. What's inside the parentheses, x plus 9. Now at this point, what we want to do is take our two factors and we're going to split them up into two separate little problems. So we're going to put x plus 4 equals 0 and x plus 9 equals 0. And so to solve it for x, we're going to subtract 4 on both sides, so x equals negative 4. And on this one, we're going to subtract 9, and we get x equals negative 9. So our two solutions are negative 4 comma 0 and negative 9 comma 0. And there you go. Now, let's try, why don't you try number 4? Well, I'll work with you on it. Let's do number 4 together. Okay, the thing about number 4 is that we need to factor this. And if we were to do A, B, C, you would see that the A, which is the x squared, is 4, and the C, which is the constant, is negative 9, but there is no B, so that's going to be 0. So we're going to have a sum of 0 and a product of 36, negative 36, excuse me, negative 36. I'm going to write that again. Now, we need to find our two factors, which are going to be negative 6 and positive 6. Those add up to 0 and multiply to negative 36. But before I go ahead and work out all the factoring, maybe some of you recognized 4x squared minus 9 as a difference of two squares. And how do I know it's a difference of two squares? Because 4x squared is a perfect square, 9 is a perfect square, and there's a minus sign in between. And remember, if we have a squared minus b squared, which is a difference of two squares, we can factor it by doing a plus b, a minus b. So that would be the shortcut for this one. Since we have 4x squared minus 9, we can say the square root of 4 is going to be 2, the square root of x squared is x, and the square root of 9 is 3. So 2x plus 3, 2x minus 3. Now I can guarantee you that's the same thing we're going to get if we do this the long way. Watch. I'm going to do it in green. Let's say we have 4x squared and we have minus 6x plus 6x minus 9. Upside down division. Take out a 2, and so we have 2x squared minus 3x, and then take out an x, so we have 2x minus 3, 2x out here, and now upside down division here. I'm going to divide by 3, and I get, I get 2x minus 3 with a positive 3 out here. So what's outside the parentheses? 2x plus 3. What's inside the parentheses? 2x minus 3. Same thing you get is if you do it with the shortcut. But we're still not done, because to find our solutions we have to make two little equations. I'm going to do those in red. We're going to take 2x plus 3 and set it equal to 0, 2x minus 3 and set it equal to 0. Now we're going to solve two little equations. So on this one I'm going to subtract 3 on both sides. So I have 2x equals negative 3, divide by 2, and x equals negative 3 over 2, or negative 1.5. And then on this other one, we're going to add 3 to both sides. And you get 2x equals positive 3, divide by 2, and so x equals positive 3 over 2, or 1.5. So if we were to write those as coordinate pairs, it would be, I'm going to use the fractions, negative 3 over 2, comma 0, and 3 over 2, comma 0, like that. And there you are. So you're just using all this information that we've used in our previous lesson on how to factor, and then the main thing you're going to do differently now is just take your two factors and split them up into two separate little equations, set them equal to 0, and find your solutions. Okay, one more time. What do we call solutions? Sometimes it'll say on the question, it'll say solve. It'll say solve the quadratic. It'll say find the x-intercepts. It'll say find the zeros. Find the roots. All of those things, solutions, x-intercepts, zeros, roots, or if it just says solve, and we're talking about an equation that has an x squared in it, ax squared plus bx plus c. What we have just done on this paper is how you would solve it. We'd factor it and split up our two little factors, set them equal to 0, and then solve for x. Okay, so hope you're doing well on that, and if you have questions, come to tutoring. Okay, we'll be here to help you. Bye.